Section of centrifugal pump. Let us see the construction of centrifugal pump. Water enters from the sump and centrifugal pump lifts the water.
What type of pump it is? Centrifugal pump. The main part of this pump is casing.
See the
First one is casing
and assembly of centrifugal pump.
These are the studs,
Parts name.
Impeller, backplate, shaft, bearing,
Suction,
housing.
delivery,
Okay, suction and discharge.
casing,
Right. This is called casing.
impeller,
Impeller.
bearing. Now watch the cut section of centrifugal pump and impeller rotation.
You want to see again which video? Clear, no? What are the different parts of the pump? Very important, huh? Because when you are fitted this, you are going to face toward your life. Pump parts and every impeller, housing, bearing, casing, stud, gland, packing, couplings. The pump is connected to the motor with the help of coupling afterwards. Following main parts, the central pump, there's the impeller, casing, suction pipe with footwall and strainer and delivery pipe. It is static diagram is shown in here. This is from the suction pipe. This is sump. Water level below that is called sump. Impeller, this is the delivery valve. This is the casing. H and HT. These are impellers. These are provided both open type and closed loop. The inside direct cross here. It is a wheel or rotor which is provided with a series of backward cross blades or vanes. It is mounted on the shaft, which is coupled to the external source of energy, which imparts the liquid energy to impeller, thereby making it rotate. You just say this video exactly how this impellers work. You come to know.
Impeller. In this video, we will discuss about the working of impeller in centrifugal pump. Casing, impeller, ground plate, water to delivery pipe, water from suction pipe. Impeller is mounted on a shaft which is coupled to an external source for rotation. Impeller blade, base plate, a wheel which is provided with a series of backward curved blades. Closed impeller provides better guidance for the liquid and more efficient.
Okay. This is open, this is closed. It's stable like this. The curves are there, no, in the blades. Takes and discharge into the discharge section. Now casing is like this. This is the pump casing. In casing of centrifugal pump is similar to the casing of the reaction turbine. It is an airtight passage surrounding the impeller. It is designed in such a way that kinetic energy of water at the outlet of the impeller is converted into pressure energy. So all energy from one form to another form is getting converted. Okay. This is kinetic energy, the kinetic energy, it is changed to the pressure energy and discharged into discharge. Watch this video.
Casing. Let us see the 3D model of the pump casing. Casing is an airtight chamber surrounding the impeller. Casing partially converts kinetic energy into pressure energy. Let us see the 3D model of the volute casing pump. Volute casing, delivery pipe, suction pipe. Volute casing closely surrounds the impeller. In volute casing, the flow area increases gradually. Let us see the 3D model of the vortex casing pump. Casing. Impeller. Circular chamber. If a circular chamber is introduced between the casing and the impeller, the casing is known as vortex casing. By this circular chamber, the loss of energy due to the formation of eddies is reduced.
Okay, section 5 with foot wall and strainer. This you should know from your side because maybe in agriculture sector.
Foot wall and
in the
strainer.
where we saw this. See, foot wall is
Centrifugal pump, delivery pipe, suction pipe. The pipe which connects the pump inlet and water in sump is called suction pipe.
below the sump, it will look like this. This is called foot wall. It is again like a non-meter wall.
At the bottom end of the suction pipe, a foot wall with strainer is fixed. Strainer filters the impurities in water before entering into suction pipe. Foot valve is a non-return valve which is fitted at lower end of the suction pipe. Foot valve avoids the reverse flow of water in suction pipe.
Wherever the pump comes in the discharge line, there has to be one non-impeller. Okay, if you discharge, it should not come back on the impeller. Where in the discharge line, it has to be one non-meter valve, and suction line, it has to be one. Maybe a foot wall or strainer, whatever. Strainer plus foot wall. This has to be remembered. See, one end of the pipe is connected to the inlet of the pump, and other end, deep into the water in a sump is known as suction pipe. The foot valve, which is non-meter valve or one-way type valve, is fitted to the lower end of the suction pipe. The foot valve opens only in the upward direction. The strainer is also fitted to the lower end of the suction line. This is a strainer. This is called foot valve. Delivery pipe, all these pipes will be rigid mostly, whatever it's flexible. The pipe whose one end connected to the outlet of the pump and other end deliver the water to the required height is known as a delivery pipe. So this is the difference. For distribution, we require one header.
Delivery pipe.
Header
In this video, we are going to see about delivery pipe, centrifugal pump, delivery pipe, suction pipe, a pipe whose one end is connected to the outlet of the pump and other end delivers the fluid at the required height is known as delivery pipe. Delivery pipe is used to convey the fluid from pump outlet point to a required designation. The delivery pipe should withstand the following factors, which are mechanical stress, chemical corrosion, thermal stress, and ultraviolet radiation from the sun. But important factor in the pipe is fluid pressure, fluid hammer, fluid acidity, cavity. Those problems are managed through material selections and designs. Mostly, the pipe materials are made in metals, composite of metals, plastics, ceramics, and elastomers.
So this the discharge line can be any metals, composite, okay, maybe FRP line or PP line, anything, depends upon the situation. Working of centrifugal pump, how the pump works. There are certain points we should remember. See, close the delivery valve and fill the liquid in the suction pipe, pump casing and delivery pipe up to delivery valve to air bubble in the pump. So because of the priming, some what do you mean by that? Cavitation. there are possible air bubble is somewhere anywhere. So to avoid that, we have to fill the from discharge line to the section line throughout the pump discharge line. It has to be full with the water. There should be no any air bubble. Completely okay. Then you have to start the pump. It's basic actually. So there is a some play is shown here. What this? The cut section is shown to you. So this is partially cut. See how the water comes here. Going to the impeller and impeller pushes the water to about the discharge line. Stop. So this process is called priming. Basically, with the filling the suction line with water. It's called priming. The electric motor is started to rotate the impeller by keeping the delivery valve in the closed position. The rotation of the impeller causes strong suction or vacuum at the eye of the cable. The speed of the impeller is generally increased till the impeller rotates to its normal speed and develop the normal hydraulic energy required for